I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. The idea of having this website is to share organized set of videos with you globally. We are going to keep the language very simple so that everybody around the globe can understand what we are talking about. In this video, we are going to discuss about direct variation. I have seen that it is being interpreted in many different ways in different parts of the country, and will address that in this video also. I have taken 5 questions which should help you to understand the topic in greater sense. At present, you can actually pause the video, copy these questions, try them out, and then look into my suggestions. Let's begin with their solution. We'll actually first talk about some basic concepts about direct variation and then solve those questions. Well, direct variation, sometimes we say that X varies as Y. What does this mean? We are actually saying that in a coordinate plane, whenever we want to draw a graph, then as the value of X changes, if it increases, Y increases. If X decreases, Y decreases. So what we get here is kind of a straight line which will always go through the center. So the meaning of this statement is, if X increases, Y increases. If X decreases, Y decreases. So that is the meaning of this particular statement. So that is one interpretation of direct variation. We may also write as X varies directly as Y. Now, most of the time, if the word directly is introduced, it means that if X equals to 0, then Y equals to 0. That is important. And if X increases, then Y increases. If X decreases, then Y decreases. So the line which goes through the origin will be rising. So what we get here is a result that we have a line which is rising, right? Positive slope. And it will pass through origin. Right. So these are the ways in which the word directly qualifies the statement. X varies as Y increases does not necessarily means that, right? So here it is X equals to 0, then Y equals to 0 is not assumed, right? It could be different. Perfect. Now there's another term which we'll be using here, and that gives more flexibility to direct variation. And the term is proportional to. So sometimes we say x is proportional to y. Now if I use the word proportional to, in that case what happens? In that case, we have given more flexibility. We have included even non-linear graph. For example, we can say x is proportional to y square. We can say x is proportional to square root of y, which are non-linear functions, correct? But they are also direct variations, right? So in this particular case, the graph could be something like this. Do you see that? Or we are saying proportional to, right? So when we say x is proportional to y squared, we are only considering this part of the graph. Do you understand? So this is when x is greater than or equal to 0. We'll have a condition, right? Because on the left side, the graph is decreasing, right? So we cannot take that part into consideration. So that happens for the value of x which is greater than 0. So when we use proportional to, in that case, the graph is as shown. Does make sense to you? Correct? Now, the proportionality sign can be changed. So if I say x is proportional to y, I can write this as x equals to some constant k times y. Now if I say that x is proportional to y squared, then we can say x is equals to k times y squared. And if I say x is proportional to square root of y, then we can write this as x is equals to k times square root of y. Does make sense to you? So when we use proportional to, in that case, we provide more flexibility to our definition of direct variation. We are not restricting only to straight lines. Does make sense to you? Otherwise, if we use varies or directly varies, we are saying straight line and the graph will always go through the origin as shown here. So with this, let us begin to answer the questions. So I hope this concept is clear. The very first question for us is, d varies directly as s if d equals to 20 when s equals to 5. You have to calculate these two things. First, value of d when s is 20 and the value of s when d is 5. So let's begin with the definition itself. We have written that d varies directly as s. That means what? That implies that d is proportional to s. So whenever we have proportional to, we can write this as equals to some constant k times s. Does it make sense? Right. So that becomes our equation, and we'll call this as our equation number 1. And we're going to use this equation to solve the problem, right? So let's now answer part A. Now we are given that if d equals to 20, s is 5, right? So we're given if d equals to 20, s equals to 5. Now this equation is d equals to a constant times s. Substituting the values, we get 20 equals to constant times the number 5. So the value of constant is 20 divided by 5, and that is the value of constant, k. So from here, we know now 4 is the value of k. And therefore, the relation now becomes that D is equal to 4 times S. Does make sense to you? So we get our second equation, which is actual definition of what is given to us. Now we are going to use this equation to solve the question. So let's now take A once again. So in A, the value of D we need to calculate when S is 20. So we know S equals to 20. We need to find what is the value of D. So using this equation, we can say that D is equals to 4 times 20, right? Since we have just derived that D is 4 times S. So using the value for S as 20, right, we substitute this value and we can calculate the value of D. So from here, we can say that the value of D is 80, right? So we have our answer. That is D is equal to 80. Now let's do part B. In part B, the value of S we need to find when D is 5. So we are saying D equals to 5. Find the value of S. Again, we'll use the same equation. So in this equation, we'll substitute 5 for D and find S. So we get 4 times S. So that means 5 divided by 4 is equal to S. Correct? So we get our answer that S is equal to 5 divided by 4. So as you can see, first step is to find the constant, right? So step 1, find constant. And then we do step 2, find values. We'll say find missing values. Is that clear to you? Correct? So we're going to adopt this strategy for all our questions. So now let's have a good look at the second question. I'd like you to pause the video at this stage, answer the question, and then look into my suggestions. Question number 2 is, x is directly proportional to y square. If x equals to 12 when y equals to 2, calculate the value of x when y equals to 5 and calculate the value of y when x equals to 9. Let us see how to solve this question. Now when I say that x is directly proportional to y square, this can be translated as x is proportional, right, to y square. So that is how we translate the statement x is directly proportional to y square. Now proportionality sign can be written as an equal to sign and multiplied with a constant, right? So we get our equation, which is x equals to k times y square. So we'll call this as our equation number 1. Now to solve an equation based on variation, we need to find the value of k. So we say that the step now is to find k, the constant of variation, correct? To find the value of k, we will use the information given to us, which is at x equals to 12, y equals to 2. Substitute the values in the given equation, and so we get 12 equals to k times 2 square, or 12 is equal to 4k. So 12 divided by 4 is the value of k, and so we get k as equal to 3. So that gives you the equation of the given example, right? So we can write down now that x is equal to 3 times y square. So this is the equation with which we'll work and find the solution to part A and of part B. Is that clear to you? Now in part A, we are saying the value of calculate the value of x, so we need to find what x is when y equals to 5. So the equation here is x is 3 times y squared, so x is 3 times 5 squared, so x is 3 times 25, or x is 75. So we get our solution that x is equal to 75. Clear? When y is equal to 5. So that is the solution. At times, we may write this as a coordinate point. So in some parts of the world, we may write like this as our solution to the given question. Now, let's look into part B. It is slightly tricky. It says we need to now find the value of y when x is equal to 9. Okay, let us use the same equation, which is x equals to 3y squared. Substituting the value, we get 9 equals to 3y squared. We can divide 9 by 3. We get this as y squared. So we get 3 equals to y squared. Now what is y equals to? Of course, square root of 3. Now the question is, should I take plus or minus or not? Well, minus 3 square is also, square root is also 3, right? So we have to take the value plus and minus. So in this case, we have two solutions, right? So we can say that when x equals to 9, y equals to plus or minus square root of 3. Does it make sense to you? Let us try to understand this concept before leaving this particular question, right? So in a coordinate plane, what we see here is x is k times y square, right? So when I say that x is proportional to y square, that means x is greater than or equal to 0, correct? And we have seen that y could be positive or negative. So basically, here we have a relation which is like a function, not a function, but a relation which is kind of like this. It's a parabola which opens on the right side, and we're looking for two answers to our question, right? So what we really found here was that for a value, these were the 2 points of our interest. Does it make sense to you? So I hope that clearly explains why the value of y has two values, plus and minus square root 3, in this particular example. I hope that helps. Question number 3. X varies directly as y minus 3. If x equals to 3 when y equals to 5, calculate the value of x when y equals to 6, and calculate the value of y when x equals to 2. So let's begin with the statement, x varies directly as y minus 3. So it means x is proportional to y minus 3, correct? We could write this as x is equal to some constant times y minus 3, clear? Now, as the first step, we need to find the value of k. To find this, we are given that x is equal to 3 when y is equal to 5. So we are going to substitute this value here. So we get 3 equals to k times 5 minus 3, or 3 equals to k times 2. So from here we get 3 over 2 is equal to k. And that gives you the equation. And the equation can now be written as x is equal to 3 over 2 times y minus 3. So the first step is, in such cases, to find the relation. The relation is x equals to 3 by 2 times y minus 3. And now let us solve part A and part B. In part A, we are given calculate the value of x when y is 6. So we need to find what x is, and we are given y equals to 6. So let's substitute and figure out. The equation is x equals to 3 over 2 y minus 3. Substituting the value of y, we get 3 over 2, 6 minus 3. So x is 3 over 2. 6 minus 3 is 3, and we get the answer as 9 over 2. Correct? And therefore, we know that x is equal to 9 over 2 for y equals to 6. Correct? At times, you may also write this as a coordinate point, 9 over 2, 6. So I hope these steps are absolutely clear. Let's now figure out how to solve part B. Here we are given calculate the value of y when x is 2. So we are saying x is 2, you need to find what y is. The relation to begin with is x equals to 3 over 2 y minus 3. X is 2, so let's write it here. 2 equals to 3 over 2 y minus 3, right? So we'll cross multiply. So you get 2 times 2 over 3 is y minus 3. So we have 4 over 3. Bring 3 to this side equals to y. Now we need to take a common denominator. So we get 3 as a common denominator. We get 4 plus 3 times 3 is 9 equals to y. And that gives you the solution 13 over 3 equals to y. Is that clear to you? Perfect. So we have our solution. So now we can say that y is equal to 13 over 3. Or we could write this as a coordinate point 2, 13 over 3. So I hope that makes sense. Question number 4 here is, given that x is proportional to y square, complete the table. Now let us see how to solve such a question. We have missing values of x and y. So in this case, we should write the relation of both x and y explicitly. We are given x is proportional to y square. So we can write this as x is equal to some constant times y square. To get the value of a constant, we will use the set of values given to us. We are given that when x is 4, y is 6. So we'll substitute these values, x equals to 4 and y equals to 6 to find the value of k. So we get the equation as 4 is equal to k times 6 square, right? So that means 4 over 6 square is 36, right? Is equal to k. Or 1 over 9 is the value of k. So with that, we get what k is. Once you have the constant k, then you can write x in terms of y square as 1 over 9 y square. Now that should help us to get the value when y is given to us and x is missing. So we can calculate this value. So for y equals to 2, we can find x is 1 over 9 times 2 square, or x is equal to 4 over 9. So we get this value here as 4 over 9. Now to find the value of y when x is given to us, it is a good idea to rewrite the given equation. So we have the equation as x equals to 1 over 9 y square. We can write this as 9x equals to y square, or y is equal to square root of 9x. Whenever you do square root, you have to write plus and minus. So we get the value of y as equal to plus minus 3 square root of x. That should help us to get the other two values. So if x is equal to 9, we can say that y is equal to plus minus 3 square root of 9, which is 3. So we get y equals to plus minus 3 times 3, or y is equals to plus minus 9. So we have two values for x equals to 9, right? You can write this as a coordinate point. So for x equals to 9, we have y as plus minus 9. Let us now find what the value will be for 1 over 4. So let me write this value here, plus minus 9. For x equals to 1 over 4, we can write y as equal to plus minus 3 square root of 1 over 4, which is y equals to plus minus 3 times 1 over 2, or y is plus minus 3 over 2. So we get a coordinate point here, which could be 1 over 4 plus minus 3 over 2. So this value here will be plus minus 3 over 2. So whenever we have a relation where y is proportional to x squared, and we are trying to figure out what is y, we could have two values, right? To illustrate, this really represents us a parabola which opens to the right side. So if you sketch a graph of this, you will get something like this. Since x is proportional to y squared, x is always positive. And y could have a positive and a negative value. So it is not a function, but it's definitely a relation. So I hope that makes sense. I hope you understand and appreciate what we have done here. Now here is the last question on direct variation. It's an application question, question number 5. The distance d through which a ball falls from a building is proportional to the square of the time taken t. If the ball falls 20 meters in 2 seconds, how far will it fall in 4 seconds? So we are given that distance d through which the ball falls is proportional to the square of the time. So d is proportional to t square. So it can be written as d equals to some constant into t square. To find the value of the constant, we'll substitute the given values. If the ball falls 20 meters, so if d is equals to 20 meters, in that case, time t is 2 seconds. So substituting these values, d of 20 meters and time of 2 seconds, we can find the value of k. So it will be 20 over 4. So the value of k is 5. So with this, we get our relation, correct? So let me write down the relation as distance d is equal to 5t squared. Now we can solve the given question. It says, if the ball falls 20 meters in 2 seconds, how far will it fall in 4 seconds? So for t equals to 4 seconds, we need to find distance. The distance is 5t squared. So it is 5 times 4 whole square, which is 5 times 16. And what we get here is 5 times 6 is 30 and 8. So the distance is 80. So our answer is that it falls 80 meters. Is that clear to you? So that is how we are going to answer this question. So I hope with this you understand completely the concept of direct variation. So we began with the basic concept, and then we discussed 5 questions related to it. So I hope with this set of examples, it is absolutely clear how to solve such questions. Again, my reference email address is anil.anilkhandelwal@gmail.com, and the website which we are developing is Global Math Institute. You can always log on to our website and see many other related questions. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.